Okay then, first of all, good morning, Costa Rica. It's good afternoon, well, it's good evening here in Belgium. I have to say, I first would like to apologize because due to the slight delay in the proceedings, my babysitter has left. So I might have a small child joining in the presentation. My presentation will be on the secure concept, which is looking at using Seascape connectivity for resilient ecosystem restoration. And I'd like to thank very much the organizers for organizing the session, and also thank them for giving me the opportunity to present more about secure. We've actually already presented secure at a UN laboratory last year. So we have to chop Costa Seascape, and we have a lot of times we have mangroves on the landward side, seagrasses generally in the more shallower water, and coral reefs. And we see this the seascape. We see this a lot in the Caribbean, but we also see this a lot in the Indo-Pacific, and we see it a lot in the Coral Triangle as well. And what's really important about the tropical coastal seascape is we have really critical ecosystem engineers. And ecosystem engineers are actually species. The beaver is actually the most famous ecosystem engineers that modify their own environment to facilitate their establishment and their expansion. And this is what we have a lot on the tropical coastal seascape. So we have ecosystem engineers of mangrove trees, seagrass beds, and coral reefs. And these are all ecosystem engineers that actually would change the habitat and allow themselves first to establish, but will also provide a habitat for other organisms at the same time. So now not only ecosystem engineers, but they're also foundation species for their habitats. And these are really important because these actually have functional traits within them. So for example, we have the coral branches in the stony corals. We have mangrove roots, and we have seagrass leaves. And these different functional traits will actually do things like they reduce water flow and waves, they'll accumulate sediment material and also organic material, and they also provide a nursery habitat. So these functional traits of the ecosystem engineers are really critical for how these ecosystems react with each other. And they can facilitate connectivity, basically, so they can facilitate the connections between each of the other ecosystems. And I'll give you some examples here. So connective theory is really when donor ecosystems facilitate the expansion and the establishment of receiving ecosystems. So this is when a mangrove, for example, would do something which will change the conditions to allow seagrass to start to establish and then start to expand. So it's when another ecosystem does something to the environmental conditions, which is a positive thing for another ecosystem. And these are connective exchanges. So they support not only the health of adjacent ecosystems, but they can also support their resilience to stressful events at the same time. So for example, to give you some examples, we have hydrodynamic exchanges, and this is when coral reefs reduce wave height and wave energy to allow for seagrasses and mangroves to establish in relatively calm conditions. And we also have sediment exchanges where mangrove forests and seagrass beds reduce the turbidity in the water column to allow for calmer, clearer water conditions for coral reefs. So this is really important for coral reefs to photosynthesize. We also have nutrient exchanges as well, where you have nutrients, mangroves and seagrasses are known as nutrient sink, which can also facilitate coral reefs as well at the same time, because they need relatively nutrient poor water. And then you also have biological connectivity, where you have a lot of exchanges between one ecosystem and the next through nursery habitats, reproduction habitats. There's also habitats for adults as well. So this is really important for these different species as well, that they'll actually move from one habitat to the other. So they have these constant biological exchanges. And your ecosystem service here is biodiversity, your fisheries. So all of these connectivity between ecosystems really cause positive interaction for these ecosystems, which, as I said before, improves their health, but also can improve their resilience for other stresses. And connectivity really is a natural process. So it's a natural occurring thing that we have between these three systems. But we feel that you can also use connectivity as a nature-based solution. So using a natural process to support, for example, restoration of another ecosystem. And not only they will also, as I mentioned before, they will increase the resilience. And also this will increase, by increasing the resilience of them, this will also increase the impact and the effects of how we can improve restoration. And I'll talk you through this in the next stage of the presentation. So how can we look at connectivity in nature-based solutions? So basically, nature-based solutions are sustainable management and use of natural features and processes to tackle social environmental challenges. And one of the big challenges we have is with restoration of these critical ecosystems. Nature-based solutions or nature-based engineering, they not only provide one solution, but they can also provide multiple benefits at the same time of the solution at the same time. So if we look at engineered only or business as usual, and these are just looking at like very hard engineered solutions, if you compare this to using things like flood control, like with ecosystems, or maybe with looking at water storage caused by ecosystems, and you look at the benefits, the amount that we get from nature-based engineering or nature-based solutions is much, much greater, and we can really gain a lot more from the benefits. But how does nature-based solution work with connectivity? So what can we do? So for example, if you want to reduce hydrodynamics to support the restoration of mangroves and seagrasses, maybe we should look at using coral reefs instead. So maybe we should first start to restore the coral reefs and then restore the seagrass beds and then the mangroves, because they have this effect on each other where they can positively support the restoration of them. Or we can look at it the other way. So if we have connectivity in nature-based solutions, but looking at seagrasses and mangroves, maybe initial thing would be to restore the mangrove forest and then the seagrass bed, because then this reduces the turbidity and the sedimentation to allow for the coral reefs to establish themselves. So it's really looking at what these ecosystem engineers do within their habitats and how we can use this within connectivity to support restoration of the entire seascape. So instead of restoring one ecosystem at a time, how can we look at to restore multiple components of seascape as well? And restoring this whole seascape is really important, because when we look at ecosystem services, and I mentioned them before, the different ecosystem services you might get with different connective fluxes. If we restore the whole seascape, we can have much more multiple ecosystem services, from blue carbon accumulation to coastal defenses from coral reefs and mangroves, to looking at fisheries and biodiversity using oyster reefs or other areas like that. So look at these multi-ecosystem services, this will be able to support more people and will allow the seascape to be much, much more resilient to multiple stresses. And this is important because 60% of people live within 100 kilometers of the coast. So it's a huge percentage of people not only rely on our coastlines for protection, but also rely on them for multiple resources. So it's important that we look at new ways of how we can do restoration. And we know that mangroves, forests, seagrass beds, and coral reefs are declining at an alarming rate since records began. So we are aware of this. We are aware of this high degradation of them either being totally destroyed from maybe unsustainable fishing practices, also being cut down to make shrimp ponds, but also we know that stress events like climate change, acidification, higher temperatures, or regional stresses like eutrophication, sargassum issues can also degrade these ecosystems at the same time. And simultaneously, the restoration failure for these three ecosystems is high. So it's expensive to restore them and it's difficult to restore them. And we know that once you've lost these ecosystems, especially very sensitive ecosystems like seagrass beds, it's very, very difficult to get them back. And that's why we think that this secure concept is something that really we can go towards on developing more resilient restoration and restoration of the entire seascape as well. And it's something that we at IMDC are developing, and we are looking for pilot projects for this. And looking at areas where we can start to do this by getting seed funding for this. So using connectivity nature-based solution was also important for so many other different aspects, for example, like the economic benefits, your social benefits, your ecosystem benefits, and your climate mitigation benefits. And these are areas that we're really trying to sell when we're trying to get the seed funding for it, by looking at ways where we can make the restoration of Seascape where it pays for itself, basically by looking at carbon credits or biodiversity credits as well, and making sure that it's very resource friendly towards the communities that are alongside these areas. So the money going from the restoration goes directly to the communities. And nature-based solution, of course, because we have already presented this at the UN laboratory session as well, where we developed some further networks. So this nature-based solution connectivity is really important, obviously, for life below water, but not only for humans, but also for ecosystems. But it also really hits in a lot of the other sustainable development goals, which goes towards the Ocean Action Plan as well. So really looking at nature-based solutions and connectivity and the connective seascape, this is really important for many different areas like gender equality, sustainable communities, clean water and sanitation, poverty aspects as well as climate action. So thank you very much for letting me share our work at the moment in the secure concept, and I think the questions will be at the end.